So welcome to the next video. Now we're approximating actually the analysis. And the simplest analysis that we can do is actually an ANOVA analysis. We can just see whether there is a difference between the groups, between those people who were exposed to fear, to anger, or were in control group, and whether they differ regarding their behavioral inhibition or behavior activation. At least here 1 scale and 4 scales here. The simplest way to do it, not the most correct, but this is also the one that you can replicate in Excel if you want, with some painful way, but would work. You go to Analyze, you go to Compare Means and Proportions, and go to One-Way ANOVA. In the One-Way ANOVA, it's a very simple test. You can also run the t-test. In the event of ANOVA test, we talk about an f-test. An f value shows you how much variance is being explained by this variable as compared to all variance explained with a model. So it will show you how good this variable explains the variance in the dependent variable. Our independent variable is our manipulation, recorded here, if you remember, 0 for control group, 1 anger, 2 fear. And we take these variables here, our aggregated scales, as the dependent variables. We, I think, don't need contrast, no, at least I don't know how it works. Post hoc, if you want to know difference between the groups, I think you have to select, there are different tests, they would all work, they're a bit different. I'm not familiar with all of them. I think we work with the Bonferroni test and 2-key test. I think we'll try 2-key. And in the options, you will need descriptives, maybe, if you have not so many variables. Descriptive is good. Homogeneity of variance test, this is very important. And means plot, we want to see a nice plot about the differences within the groups. Click on continue and click on OK. And the test is running. Let's see. Descriptives, you can see how many people were in a group for each variable. For instance, in anger, we had 50 people. The mean value of this B scale was -5.3. It means 0.53 standard deviations below the mean. There's standard deviations and other things that you find in this table. Test of homogeneity is important because it shows whether you're allowed to run the ANOVA test. It should not be significant, and significance is everything that is higher than 0.005. Not as usually 0.5, but 0.05, so strongly significant. If the test is strongly significant, it will be here in the significance. This is the p-value in this table. Then it means that the groups differ in the distribution of data. Let's say one is exponentially distributed and one is normally distributed. And then you cannot compare the groups because the mean would mean different things. And you are allowed to compare the groups if they have the same type of distribution. This is what Levine's test is doing. That's why when you analyze your data for your results section, before you run the ANOVA analysis, you have to show the Levine statistic, and the Levine statistic is being reported as an F value. It's also an F value with the degrees of freedom. So it will be F value, Levine test F value. Brackets, open the brackets, 2, 164, so degrees of freedom 2, 164, closing bracket, equals to 192, with a significance p-value equals to 0.825. It means it is not significant and we can use the test. If it would be significant, then you will need to run a different test, not an ANOVA test. You will need to run a non-parametric, I don't remember exactly, I think Smirnov-Kolmogorov test, but I'm not sure. And now we go to actually ANOVA test that will show whether there are statistically significant differences between the groups. And look at this one. We have two groups, two variables where there is statistical significance. For the B factor, between our control group, fear group, and anger group, we have strongly statistically significant results. F value of 239 with degrees of freedom of 2, and 166. Yeah, so this is between the group. Whereas within the group, 144. I don't remember which of them should you write. The F-test is reported not only as value and p-value, but also with the degrees of freedom. The first one is this number here, and the second one I think is total degrees of freedom, or maybe within the group. I don't remember, you have to check. Can happen that, yeah, don't remember. And We know that they are significant, but in how much? To know in how much, that's why we need a descriptive test. So it seems that this data, and this data, they are statistically significant. They really differ on a statistically significant basis. That is why we also run the nice, I'll come to the graphs where you can see how the graphs look like. And now you can see what were the values for each of the emotions, fear, anger, and control group. And it seems that fear was much higher in behavioral inhibition. So it means actually what we expected. Anger was much lower in behavioral inhibition. This one is positive, this one is negative. And control group was pretty close to a 0. Their results for other groups, they were significant only for the next group, BS fun-seeking. And let's look at the fun-seeking, what happened with the fun-seeking. It seems that those who were afraid and those who were angry, they were lower in fun-seeking than those who were in control group. So more or less, the lowest level of fun-seeking was in the fear group. Anger was above 0, so higher than 0, and control group was even higher. That's why we need an additional test, and in this event I took the post hoc test 2-key, and it compares the two groups, anger against fear, and you can see anger against control group. In the first case, they are statistically significant, and those people who were angry compared to neutral condition, they were much higher. They were much higher in behavioral inhibition, so they were inhibited much more than people from control group. And fear against control group did not differ, but fear differed against anger very strongly. So as compared to anger, fear was much so anger was much lower in the behavioral inhibition, and fear was much higher in behavioral inhibition. And you can also look for other group comparison, like this is the comparison not among all groups, but two groups, and you can see whether there is a difference between group fear and anger. And as you see, the next results are here significantly. Fear against anger are significant. Fear against control group are significant, and fear against anger are significant for the behavioral activation fun-seeking test. I don't know how to interpret other tables. Anyway, if you are interested in how to run ANOVA test and F-test, I can recommend you the channel howtostats.com. How to as a number stats.com, or how to stats on YouTube channel. What is the issue? Theoretically, this test is already sufficient. We can support hypothesis 1 because we see anger is low in behavioral inhibition and fear is high in behavioral inhibition, so people who are afraid didn't want to engage, and people who are angry, actually the opposite is true. And we also see that here is very low in activation, and anger is actually much higher in activation. In this event, we can say that we can support hypothesis 1 fully. No, they will all be partially supported because we have the behavioral activation scale. We had 3 different subscales, and we supported only on the behavioral activation scale fun-seeking. For the drive and reward responsiveness, we didn't have significant results. That's why we can partially support hypothesis 1 and partially support hypothesis 2. The problem with this test is that actually it takes only the pure effects into account. For some cases it is sufficient, but as we have control variables, we would like to include them. But how can you do it? Look at the test, one way ANOVA. Where can you put an additional independent variable? It's not possible. The 2 ways to do it is, the first one is through the analyze general linear model, and you go to, if you have one dependent variable, univariate. If you have several dependent variables, you go for multivariate model. We go for multivariate because we have 4 dimensions that we want to test. Here they are. As the dependent variable, we take our scales that we want to see whether they are integrated. As the fixed effect, we take our manipulation recorded group. It will just look at different groups. And now we can also include gender as the fixed factor because it didn't change during the test, so gender and manipulation stay the same. And as a covariate, we add age. So as you see, this test will make ANOVA plus regression analysis. Now we need to also specify the model. If you don't click anything, it will be full factorial model. It means it will test the effects of manipulation on all 4 scales, gender on all 4 scales, age on all 4 scales, and interaction between manipulation and gender. Let's say where a female were more responsive to some types of emotions. Theoretically, it shouldn't be the case. That's why we just say, no, we don't need the full factorial. We want to see only the direct effects. Build terms. So manipulation directly, gender directly, age directly. If you assume that males with age or females with age would have different perceptions of something, you can make also the interaction. So we click here on interaction, and it will also look at the interaction of two things. We don't want to do it, we just make the main effects. Click on continue and click on OK. The first thing that you will see is I think I forgot to click something, so forget about it. I'll just delete this test because I just forgot to click some of the important things. Go one more time, multivariate. Now we have to go to plots. You can add plots, we'll do it later. It will be a nice graph, although why not? Let's add the plot for manipulation. And we can add a plot for gender and even for gender. So first of all, add and gender and separate lines for manipulation as horizontal axis, separate lines for gender, if we assume that things might interact. I assume that not, but let's show a nice graph. Important here, options. By options, click the descriptive statistics, estimated effect size, parameter estimates, and homogeneity test. Because it is an ANOVA test, we need to be sure that we're still allowed to run it. Click on OK, and click on OK. So now the test will be calculated correctly, hopefully. We have descriptive statistics where you can see, similar to there, how many males and females were in the control group. Now we have more groups because we included two categorical variables, gender and manipulation. And now you see how many females were in the control group, or what was the value of females in the control group on the BIS scale. What was the value of females in control group on the BIS scale, and how many of them were included into this condition. Then we have the boxes M test of sphericity. I think it is similar to Levine's test, so it should not be significant, but please check. This is the F value, these are the degrees of freedom, and this is significance level. As far as remember, it should not be significant. This is the multivariate test that will show that if you include all variables into one equation, what is going to happen. And you see we have strong impact of manipulation and no other significant effects. And for manipulation, if you want to report, these are 4 tests. The most conservative one is the p-least trace. That's why usually we report the p-least trace. As a multivariate test for all the variables, you can include the p-least trace for manipulation, which will be F value, F, with the degrees of freedom of 8 and the second degree of freedom 320. This is the value 4.779, and the significance value is highly significant 0.001. The other things you don't need to include because they are not important. And this is how much partial eta squared shows how much variance in the dependent variable is explained by the independent variables. Now it's all of them. So 10% of variance is being explained by manipulation, while all other variables are also being included. Here's our Levine's test. Again, because in the next step, after doing the test with all the variables, we're going to do the step for each variable separately. And again, if you want to run an ANOVA test, and this is ANOVA F test, you need to be sure that the distribution of the data is the same, so both normal, both exponential, and so on. And it should not be significant on the level of 0.005. It is not significant far away, so we can use the test. And now we can see whether we have some significant corrected model. Just ignore it, intercept, start with manipulation, and it seems that we do have significant effects of manipulation BIS, and we do have significant effects of manipulation BIS. And if you look now in these variables, I just want to check one more thing, then these values will be almost the same or very close to those that we had in the ANOVA test. So look at this one, 10,794,001 and 548,9003. Let's go to the ANOVA test that we did before. Where was it? And 10,780,001 and 5.414 at 004. So almost the same values. So what we have now, we had really the test that shows us the same as the previous test showed, but we also have the effects of gender, nothing significant. Age, look at this one. Age showed some significant effects on the fun-seeking factors. And the partial test correct, it explains only 2.6% of variance compared to manipulation that changed 13% of variance explained by only one variable, which is pretty cool. You have the R-squared. It means how much variance is explained in the model with this factor, and you see for the A, where do we have A? Here it is, the A, BIS. For the whole model corrected factor, you can see it's 10.9 explained for the BIS factor with all the variables. And parameter estimates are the set of regression. So at the end, it is the same as dummy coding variables. It will show you also how you look at gender. It means we include gender as a dummy variable, 0 and 1. So we compare, in this event, female against male. So, and you see it's not significant, but if it would be significant, you can say that female participants showed a lower score on BIS, minus 0.849, as males. The same value with a plus would hold for males. So males showed a higher score on BIS scale of plus 0.49 as compared to females. And the p-value will hold. So the only thing that differs is the sign. Here we have manipulation. We compare against fear too, and you see that anger is statistically significantly different from fear, and control group is not different from fear. So we compare against one of the variables. So in this event, it would be interesting to compare against the control group, but we compare at the moment against the last one. SPSS automatically compares against the last value, which is the fear. And the same here, you see we have one significant result, and we have some weakly significant, this intercept doesn't count, or manipulation. Here we see significant results. Control group is statistically significantly different from fear. And anger is statistically significantly different from fear. So, and gender is not statistically significantly different, but here age is different. It means with each year of age, the score of behavioral activation scale fun-seeking is dropping. So the older people are, the lower the behavioral activation on this fun-seeking scale. As you see, we can again support our hypothesis even after inclusion of control variables. And it means if we include control variables, the model still remains robust, and we also control and check for other alternative explanations of why people can be seeking fun. Let's assume somebody said that females seek for more fun than males. If yes, we would have seen it on the significant result here, but it is not. Again, more or less the same links as we had before, now for gender and age, but it was not significant, that's why we can ignore it. And as you see, also no huge differences, so most likely these items were not significant, but if they were, you can depict them in this nice way, and you can even double click it, and then you will have something like this, and then you can change some names or change the fonts and copy this picture and use it for your master thesis or your academic work. Change the colors, change the texts, whatever you need. For instance, manipulation recorded makes no sense. That's why let's call it just a manipulation group. Manipulation group to make it nicer. Let's make it most journals, they are black and white, so probably we need to change the color. Can I change the color? Yeah, we change the color to just black, but instead of this, we make it dotted. I don't remember where exactly, but somewhere you can make it dotted. I don't see where it was. Type of line, no, I definitely had it somewhere. Properties, select, window, thing. Up, one more time. Don't remember what it was, but you also can change the line, the type of the line to a different one. Okay, so with this in mind, you know now how to analyze data, and you know how to test and support your hypothesis. So we can see that both hypotheses were supported, partly supported for the BIS, two factors which were in my event. So think about your data can be different. In my event, we had significant support only for BIS FF fun-seeking scale, but not for drive, not for reward responsiveness. And that actually was it. If you have any questions or if you want to know more, please let me know.